Okay, good morning. So let us continue today's lesson. So we learned a little bit about systems of equations in the last session. And we also learned that it is always good to have both perspectives towards a system, meaning that looking at the system from geometrical point of view, and of course looking into the system from algebraic point of view. Both of them are necessary. So now, today I want to mainly focus on algebraic part so that we can find the answer, the solutions to the systems using algebra. Of course, the systems that you are dealing here are not hard. So let me just start giving you examples. So I would say that example, solve the following systems. Okay, so let us take one from your book. So we want to solve this system together. So 3x plus 2y equals to 4, and you have 2x plus y equals to 1. So we are supposed to find a value for x and a value for y, so that if I replace x and y in this equation with those values, it becomes a true equality. Simultaneously, if I do the same thing with the second equation, it also turns out to be a true equality. Okay, I introduced yesterday that the main strategy in tackling every system, not just very simple system like this, every system is method of substitution or elimination. So what does it mean? It means that first of all, first of all, you need to choose one of these equations. It doesn't matter which one you choose, technically it will give you the correct answer at the end if you follow everything right. But of course, from practical point of view, it is important to choose the better one. Your choice should be a wise choice at this step. For example, here, if I look at my variables x and y, we have 3 as the coefficient of x and 2 as the coefficient of y. If I want to make one of them as a subject, hello, please keep quiet. Hello, can you hear me? Buhdan, can you hear me? So please keep quiet. Yes? So here, I want to find one of these variables alone so that I can go to the next equation and make it do the substitution. If I choose this equation, it doesn't matter. If I want to make y alone, I have to divide by 2 at the end. If I want to make x alone, I have to divide by 3 at the end. And usually when you divide, you have to deal with fractions. So I myself prefer to avoid working with fractions if possible. Sometimes it is not possible, then you have to deal with that. But if it is possible, I will try to avoid that. So it means that before starting to solve the equation, think about which one is more appropriate. Can you tell me which one is now more appropriate to choose? Yes? The second equation. And which variable is better to choose? Y, because y has coefficient 1. But of course, if the y coefficient is not 1, then it is up to you which one to choose, yes? I want you to know, technically it doesn't matter at all. If you do the calculations right, that would be the same. So let us concentrate here and concentrate here. So then it means that, so let me change my color, the blue is the solution. So here I go and make y alone. So y becomes equal to, I have 1 here, I move 2x to the right, it becomes negative 2x. Yes? And then what I do, I go to the equation that I haven't used and replace or substitute this expression for y. Yes? So I go here, I would write 3x, and then I would write plus 2, and then instead of y, I replace it with this, and equals to 4. So then what happens, I am facing one single equation, and the good point is that I no longer have two variables, I have just one variable. So that is a very simple problem. So let me solve the problem here. So I just solve it just like Math 1C. We just multiply, so it becomes 3x plus 2 minus 4x equals to 4. And then I have 3x minus 4x is negative x. And I move 2 to the other side, it becomes 4 minus 2, which is 2. But I want to make x alone, so x becomes negative 2. Yes? I divide by minus 1. This becomes x, this becomes minus 2. But you cannot stop here, because when I ask you to solve a system, I need a value for x and a value for y. The value for x is found here. You have three choices now for finding y. You can put it back in the first equation for x and then find y. You can put it in the second equation, but you can also put it here. This is better, because if you put it here, you immediately get y. You don't need to do extra algebra. So then this is why I take this with me and put it here. So this means that y becomes y minus 2. Instead of x, I put minus 2. And then it becomes 1 plus 4. And then finally y becomes 5. So that is the answer. So if you, what you need to write for the answer is x equals to minus 2 and y equals to 5. So this is something that you have to provide at the end for this problem. So if someone asks you what is the meaning of these two numbers, you would say that these are the values, these are the only values, that when I replace x and y with those values, both of them are true. You can check. 3 times minus 2 is minus 6, 2 times 5 is 10, 10 minus 6 is 4. But not only this one, this also will work. Let us see. 2 times minus 2 is minus 4, y is 5, minus 4 plus 5 is 1. So you see, those numbers make this right, make this one right as well. So that is a solution. And there are no other solutions, yes? Because when I solve this, I get only one solution. When I have one solution for x, I put it back here, I get only one answer for y. So there are no more solutions. So that is the end of this problem. Yes? Okay. I want to show you that it really doesn't matter if I choose this one. But you will see that the solution would be a little bit harder. Okay? So this is the best way of solving this, I would say. But if I want to solve it in a different way, so let me write it in a different way. So now let me this time target this equation. Let me target this equation. And let me target x variable. Let us see what happens. Assume that you don't do this wise decision, you don't make this wise decision, and you make this a little bit inefficient one. And then, so what you do, you just write this. You would write 3x plus 2y is equal to 4. And then you move this to the other side because your target is now x. So you're supposed to make x alone, so it becomes 4 minus 2y. Then I want to make x alone, I have to divide by 3. This becomes 4 over 3, and this becomes minus 2 over 3. Okay? This is also possible. But then, because I have used this equation, I have to go to the other equation and do the substitution. So in the second equation, I will take x away and replace it with that expression. So what will happen here? This becomes 2. Instead of x, I put that expression. And then plus y equals to 1, yes? I get this equation. Of course, if of course this is not very hard, but if you compare this equation that I have to solve with this equation that I solved in the previous choice, I hope that you agree with me, this was easier. And because we had a better decision there. Okay, so now let us solve the problem. I have to multiply this, it becomes 8 over 3. I multiply that, it becomes minus 4 over 3y. And then I have a y alone here equals to 1. Then I want to get rid of fractions if possible, so I rescale it by 3. I multiply this by 3, it becomes 8. I multiply this by 3, it becomes 4y. I multiply this by 3, it becomes 3y. And I multiply this by 3, it becomes 3. Then what I do, minus 4y plus 3y is minus y equals to, I move 8 to the other side, it becomes 3 minus 8, it's minus 5. And then y becomes 5. And then that is exactly as we got here. But here in this situation, I got x first, and then I plot this back, and I got y second. But here I am getting y first, but that's the same answer. And then what I do, I have again 3 choices. I can take y, put it here and find x, or I put it here and find x. But here I think it would be better if I put it here and find x. So then x becomes what? 4 over 3 minus y is 5 multiplied here, it becomes 10 over 3. But the denominators are the same. So 4 minus 10 is minus 6. And then minus 6 divided by 3 is minus 2. So you see, it's not a big deal because this problem was not hard at all. But this efficient decisions will affect if the problem itself is harder. Okay, so I want to see that, okay, if you write this, that is 100% correct. If you write that one, that's also 100% correct. But I would say that this was a little bit easier because I didn't have to work with fractions. Okay, I want to teach you another method for solving the system here, but only for these kinds of systems. So still, method of elimination is the main strategy to tackle any kind of systems. Some people call it method of addition. That's a good name. You will see why that's a method of addition. So in the method of addition, so let me describe it here. So I wouldn't call it a second method. Both methods is the substitution method. But let us change the strategy a little bit. Sometimes it is easier. Okay, so let me take this system with me. Yes, so here, let me write the system again here. So I have 3x plus 2y equals to 4, and I have 2x plus y equals to 1. Okay, so here my goal is to get rid of one of these variables again, but instead of elimination, I want to use addition method, meaning that, for example, let us try to get rid of y. Okay, how? If I start adding these two equations, there is no way to get rid of one of them, because if I add this by that, 2x and 3x becomes 5x, and y plus 2y becomes 3y. Again, I have both x and y. I want to get rid of one of them. So the point is here is to rescale one of the equations in a way that the coefficient of one of the variables become opposite to each other, so that when I add them, that one is gone. Let me just tell you, it's very simple. For example, I multiply this by minus 2, this equation. Let us see what happens. Then this becomes minus 4x, and then minus 2y, and then this becomes minus 2. Yes? And now I take this new equation. By the way, this equation is equivalent to that equation, because when I multiply it by 2, I get this one. If I want to go back, I can divide by minus 2. So there is no difference in algebra between this equation and that equation. They are equivalent. They are not identical, but they are equivalent. So then you immediately see what happens, and I think this is the simplest way to do it in this case. If I start adding this side by side to this, what will happen? I have 3x will be added to minus 4x. I will be left with minus x. And then positive 2y will be added to negative 2y. It is totally gone. And then 4 minus 2 becomes positive 2. And then x becomes negative 2. It was much simpler. Yes, that is exactly the answer that I got there. So, this method of addition is good, usually for these kind of simple systems. Okay? But for a little bit harder systems, method of substitution is the main strategy. But I would myself prefer to solve this in this way, rather than substitution or elimination. When this x equals to minus 2 is found, I have to put it either here, or there, or even here. But here is no good because that numbers are bigger now. So I will myself prefer to put it here. So then I would put it here. This becomes minus 4 plus y equals to 1. Then I move it to the other side. It becomes 5. And that is exactly the answers that I got. So that is the method of addition. Is that understandable? So let me give you an example. I want to solve it again in two different ways so that you yourself can compare. But it doesn't matter. You can choose this in the exam if you want to, or you can choose that, or whatever you like. Or it doesn't matter. If the steps that you are taking are logical, that's okay. So let me give you another example. Number 2. Let me see if there is a nice. Yeah, let us take this one. So we have 3x plus 5y equals to 4, and then I have 2x plus 4y equals to 3. Okay, I want to solve this problem with two methods. That's method 1, substitution, yes? So here you see, I don't know which one do you prefer, which equation and which variable to make it as a target. So you see here, it is inevitable. I have to work with fractions here if I want to use. So, but which one do you choose and which variable do you choose? Usually you think. Yes?
X on the second one.
X on the second one is probably better because its coefficient is smaller. It doesn't matter that much, but it's good to know. So let me just take this and then make x my target. Okay, what I can do, I have to make my target alone. So I move 4y to the right, so it becomes 2x equals to 3 minus 4y. Then I have to divide, I have to make my target alone, so I divide by 2, x becomes equal to 3 over 2, and then I will have minus 2y. But then be careful, you are not allowed to put it back in the equation that you have used right now. You have to put it back in the equation that you haven't used so far. If you put it back in the equation that you have used, you get a true equality independent of what you want to calculate. But I have to put it back in this. So what happens? It becomes 3. I take x away and substitute it with this substitution method. Plus 5y is equal to 4. And then I multiply 3 there, it becomes 9 over 2 minus 6y plus 5y equals to 4. Okay, I myself prefer to get rid of fractions, so I multiply by 2, but before that, I know the answer to this part, minus 6y plus y, is just minus y. So I multiply everything by 2, this becomes 9 minus 2y equals to 8. I move 9 to the other side, it becomes minus 2y equals to minus 1, because 8 minus 9, and then I have to make y alone. I divide by minus 2, it becomes 1/2. So y is 1/2, or in this case you can put 0.5, but if it is 1/3, you are not allowed to write 0.33, that is an approximation. When you found y, you can put it here, You can put it there, or I myself prefer to put it in this equation. So I put it here. Then I get what? X is equal to 3 over 2 minus 2 times 1 over 2. But then this becomes 3 over 2 minus 1. Okay, and again the answer is the same. This is a coincidence. X and Y are the same. X is equal to 1/2, and Y is also equal to 1/2. So I would write my answer is X equals to 1/2 and Y is equal to 1/2. So this is method of substitution. I don't think that's a hard problem at all, so you know how to do that, yes? But now, let me solve the same system, but this time using addition method. So let me write everything from scratch again. So let me just write the system here in front of your eyes. So I have 3x plus 5y equals to 4. And then I have 2x plus 4y equals to 3. Okay, so here I want to multiply one or sometimes both equations by appropriate numbers, but with having this in mind, I want to get rid of one of the variables. Okay, so this you need to have in mind. If I add them side by side right now, I will not be able to get rid of one of them, because if I add them, it becomes 5x plus 9y equals to 7. Still, both of them are there, x and y. If I want to get rid of one of them, you should have your target first. For example, because the coefficients of my x are smaller, it doesn't matter that much. These are simple problems. So let us make x target to get rid of x first. If I want to get rid of x, can you tell me what to do? Multiplying one of them by a number will not work. Of course, if you multiply them by a fraction, it will work, but I want to avoid fractions as much as possible. And I want to get rid of x, for example. Okay, do you have any suggestions for me? Yes, Will?
Multiply by 2 in the first one and by 3 in the second.
Okay, so that's exactly. I will multiply it by 2 here, but not by 3, by minus 3, yes? Yes? I multiply the first one by 2, multiply by second one by minus 3. What I have in mind, I want to make these coefficients the same and opposite so that when I add them, they are gone. That is my strategy. That is, if you know the strategy, then you can do whatever you like to, but this is one good way. So then this means that I can multiply this here, 6x plus, don't forget to multiply everywhere, 6, 10, 8. And then this becomes minus 6, minus 12, minus 9. And then I add them. When I add them, this is gone. And that was the reason that I chose these two numbers. So this is gone, but 10y minus 12y becomes minus 2y. On the right hand side, I have 8 minus 9, which is minus 1. And then my goal is to find y. I divide by minus 2, it becomes 1/2. And that is exactly the answer that I have there. Yes? But now when I found y, I can put it here, I can put it here, but these numbers are bigger, so I prefer the original one. Which one I prefer? I prefer here because this is even. When I multiply it here, I get. So I will put it here. This is my preference. Of course, if you put it here, that's also okay. So then it becomes 2x plus. In your head, you can calculate it. 4 times 1/2 is 2. And then you have 3. And then you move 2 to the other side, it becomes 1, so x becomes again 1/2. So you see what you get in this way is exactly identical to what you got before. So that is your preference, which one you want to choose. But I want to tell you that if the system becomes a little bit more complicated, for example, if I have second powers of x and y, if I have harder questions, usually this method will not work. But that method of elimination or substitution is still the main strategy, yes? Is that clear? Okay. The next part of the lesson that I want to teach you now, yes, because I can teach this one as well and then I can stop. If I have more equations and more variables, might be this, you have already seen this in school, I think, but might be you haven't seen how to solve systems of 3 equations and 3 unknowns. Yes? Okay, let me start this by giving you an example. I will choose my example from the book. I think the example is good. Okay, so any questions so far? Okay, so let us start this new lesson. That is also an interesting part, and we have a lot of applications with systems of these types. Okay, so still I am continuing this example. So which example? Number 2, it was number 2, so I will write here number 3, but I change it from a system of 2 equations in 2 unknowns to a system of 3 equations in 3 unknowns. I want to, before teaching you how to do it, I want to ask your opinion about that, because in principle you should be able to guess how to do it yourself. So number 3, this is the equation that I want to solve. It's x minus 2y minus 2z equal to 0, and then I have x minus 3y minus 5z equals to minus 1, and then I have 2x minus y plus z equals to minus 5. Okay. So you see here I have a system. Again, these curly brackets means and. But how many ands you have here? 2. Because I want to have this and this simultaneously. So what is the meaning of solving this system? It means that finding all triples of numbers, x, y, and z, so that if I replace x, y, and z in each one of these equations, the equality becomes a true equality. Okay? Simultaneously, I want to satisfy them, not separately. Okay. Let me just go to algebraic point of view, and then I will, of course, this is beyond the scope of this lesson, but I wanted to ask your opinion about geometrical point of view of thinking about this problem as well. Okay? That is just optional. But algebraic method is mandatory, so you need to know how to solve these systems. But before I teach you how to solve the system, I want to hear from you. What will be your strategy if you want to solve this system? And I mean by strategy, I mean a method that more or less works for all cases. Yes?
Maybe like a form of substitution. So you first separate z, put that into another equation, then substitute, then put x or y alone, and then put that in the third equation.
Okay, if you think it in this way, I think it becomes a little bit messy, but you start it very correctly. The starting point is correct. Because what is the strategy? The strategy is to make one equation with one variable. The way that you mentioned is completely correct. I start from what you said. Yes? So it means that I choose one of these equations and target one of these variables to make it a law. Let us, for example, which one do you prefer? For example, let us choose the first equation. For example, if I choose the first equation, which is the best target here? The optimal way. Of course, I told you it doesn't matter which one you choose, but if you take this equation, which one do you prefer to make a target? X. Because the coefficient of x is 1, and I want to make x alone. So I move these two. But if I move these two to the right, x is not written in terms of one variable, it is written in terms of two variables. And I go to the second equation and I replace x, I substitute what I got for x here, and I also substitute what I got for x there, then I get a new system of two equations in two unknowns. So you see, it means that there is only one more step. So you take this one, let me just tell you what. I take, for example, this one, and I target this variable. Okay, then I want to make this alone. So it means that I move whatever else to the other side. So x is here. Minus 2y goes there, it becomes 2y. Minus 2z goes there, it becomes 2z. Yes? But I substituted here and there. So it becomes a tedious calculation a little bit, but that is what it is we have to deal with. So instead of this one, we do it patiently. Instead of this x, I write this expression. So it becomes 2y plus 2z. And then after that is finished, I have minus 3y minus 5z equals to minus 1. And I simplify this a little bit. So 2y minus 3y becomes what? Minus y. And 2z minus 5z is minus 3z. And it becomes minus 1. So I put it in a box for the future. But still it's not finished. I will take this one and substitute here as well. So what happens? It becomes 2. And then what I have, instead of x, I put that expression. So 2y plus 2z. And then I have minus y. And then I have plus z equals to minus 5. And then simplify this expression. So it becomes 4y, 4z, and then I have minus y plus z is 5. Is minus 5, sorry. And then I have 4y minus y is 3y. And then I have 4z plus z is 5z is equal to minus 5. Then I put this also in a box. So now you see that I cannot solve this alone because I have still two unknowns left for me. I cannot solve this alone, still I have two unknowns. But considering this and this simultaneously, it is still a system, but in two equations and two unknowns. So you see that it becomes really tedious. If I have four equations with four unknowns, the strategy is exactly the same. But you need to go step by step. You need to reduce it to three equations in three unknowns, then you have to reduce it in two equations in two unknowns, and then you have to reduce it in one equation and in one unknown. Then you go backward again. So that is what it is, and this is really tedious. So now assume that if I have hundreds of equations in hundreds of unknowns, which is actually a very possible thing. For example, if you want to find the currents in branches of an electric circuit, that is probably very common. And then it is really important to study these things systematically so that you can make algorithms out of it so that the computer can solve it for us. Because it could be very, very messy, you know. I will talk a little bit about this. But let us not be distracted and continue solving this problem. I don't think you will have any problems. So it means that when you reach to this step, it means that you momentarily forget about your original system and set up a new system in which one equation is this and another equation is this. And actually here you should in principle be relieved, because this equation is this system consists of two equations in two unknowns, and you already know how to do that. So you solve it. How should I do that? Then you have two options here. If you want to, you can use method of elimination once more, but if you want to, you can use addition method. That is up to you to decide. I don't know, which one do you prefer here? Let us do it with addition method. Yes? For example, if I want to use addition method here, of course I can continue with elimination method, but let us do the addition method. I myself prefer to multiply it by 3. Do you agree? Because if I multiply it by 3, this becomes minus 3y, and then when I add it here, it will be gone. So let us continue with this strategy. I multiply it by 3. It becomes minus 3y minus 9z is minus 3. And then it becomes 3y plus 5z is equal to minus 5. And then I add them. This one and that one are gone. Minus 9z plus 5z is minus 4z. And minus 3 minus 5 is minus 8. And finally, I get at least one of the variables. Z is equal to 2. One of them is found. Okay, now that I know z is 2, I go to the original system, choose the smaller one, with a smaller, containing smaller numbers. I put it here, for example. I would say that minus y, minus 3 times z is minus 6, is minus 1. I move 6 to the other side, minus y becomes positive 5. But I want to make y alone, so y becomes negative 5. And now, how should I do it for finding x? The original equation. I have y, I have z, I put them back here, and I get my x, and the problem is solved. Yes? So what I do, I will go back here and write x is equal to 2 times y is minus 2 times minus 5 plus 2 times 2. So x becomes negative 10 plus 4, so x becomes negative 6. And then what you have to provide as the answer is not a pair of numbers, is a triple of numbers, yes? So its answer will be this. X is equal to minus 6 and y is equal to, what was that? Minus 5, and z is equal to 2. If I ask you how many solutions are there for this system, what do you say? 1. Don't say there are 3. Of course there are 3 numbers, but the whole package is one solution. Yes? And that is the solution of this system. Is that understandable? So I hope that if you are patient, you can definitely solve systems with 4 equations in 4 unknowns, 5 equations in 5 unknowns. But of course it becomes very tedious because you have to do it step by step. Yes? Is that clear? So that is the strategy for solving these systems. But now let me try your intuition a little bit. What is the idea of geometrical solving of this problem? How you should see the problem? Because how many variables are involved? I have x, y, and z. Definitely it cannot be a straight line. Because a straight line, of course, it might be a straight line in space, but I have 3 x, y, and z. I don't know, if you study, for example, a little bit further, you will realize that any of these equations represents a plane in a space. Yes? So if I use GeoGebra to draw this, I cannot go to the 2-dimensional version of GeoGebra. I have to go to the 3-dimensional version. Yes? So then this will become a plane. A plane, you know what is a plane. For example, the surface of this disk is a representation of a plane, but plane goes to infinity from all sides. So it means that if I have a plane, I divide the universe into 2 parts, yes? So that is the meaning of a plane. So if you have that plane and that plane, they might cut each other. For example, I don't know, for example, assume that this is one plane and this is another plane. If I have this situation, this plane and that plane cut exactly at a line. So the intersection between these 2 planes is a line. And then there is another plane coming in and cutting this line at a single point. And that point in a space is the meaning of geometrical intuition behind this. Is that understandable? Now, I don't want you to understand because that's just optional. I want you to see what is the meaning of solving this system from geometrical point of view in the more advanced mathematics, you will learn that this represents a plane, the same here, the same here. So when I am looking at the intersection of three planes, it is a little bit complicated to imagine, but you can just understand. I have three planes. I want to find a point that lies on those three planes simultaneously. Yes? But here, what I expect you in this course, you should be able to solve these systems. And definitely you get questions of this type on the exam. Yes? Is that clear here? Okay, let me try to pause this recording a little bit. Go back here. Okay, so if you want to understand a little bit, I don't know if you can go and to the three-dimensional case. I go to view, I take this graphic away, and I go to 3D graphics. Okay, so you see, if I want to go to space, I will have 3 axes instead of 2. Yes, I just want to give some feeling, to get you some feeling about this. You see, this will be my x-axis, this will be my y-axis, it's on the plane, but I have an extra axis that is called the z-axis. Okay, and then for example, let me just put those equations in to see what GeoGebra will produce for us. Okay, so I will type this equation here, x minus 2y, and then I have minus 2z equals to 0. So that is what you get. It's a little bit, so let me try to make it a little bit nicer. So this is the grid. So if I change it, you see, I get a plane. Of course, this is just one portion of the plane, because this, forget about the gray one, this, I don't know, greenish or reddish one, greenish or bluish is just the plane. Yes, I can of course get rid of that if you don't want to see this. Show grids, yeah. That would be your plane. And I hope that you can see this plane is passing through the origin. Could you anticipate that this plane is supposed to pass through the origin? What do you think would be the coordinates of the origin in 3 dimensions? In 2 dimensions, the coordinates are 0 and 0. But in 3 dimensions, what do you expect, yes?
0, 0, and 0.
0 and 0 and 0. But could you anticipate, before seeing it in GeoGebra, that this plane will definitely, you don't have enough knowledge about the planes, but you should be able to anticipate that this plane definitely passes through the origin before seeing it in GeoGebra. How?
Since the equation equals to 0.
Yes, exactly. Because even though you do not have enough knowledge about these mathematics, but it is not hard to see that instead of x, y, and z, if I put 0, 0, and 0, this equation is automatically satisfied. So it means that the origin, whose coordinates are 0, 0, and 0, will definitely pass through the origin. Is that understandable? So that was something that in principle you could foresee. And now let me go here and try to draw the other one. So x minus 3y, yes, and then I have minus 5z equals to minus 1. Okay, so that is another plane. So you see, this is something like this. So 2 planes are cutting each other. And I think it would be good if I change the color of one of these planes to a different one. So let us make it, I don't know, red. Okay, now you can see. So far I have 2 equations. Okay, if I just stop here, I just want to test your understanding. If I just stop here and I write 2 equations, but with 3 unknowns, how many solutions do you think are there? Yes, Sergey? Infinitely many. Can you point, where are they?
On the intersections
Between these 2, exactly. So let us see if GeoGebra can provide us with the intersection. Intersection between, okay, I have to go here. Intersect 2 surfaces. I choose this, and I click here, and I click there. So you are right. The intersection are all the points on this line. Do you see that? Let me just try to move it a little bit around so that you can see it. You see? So, yeah, 3 dimensions is a little bit hard. So this is the way that we have it. momentarily I can get rid of axes so that you are not confused. So this is the situation that I have right now with two planes. And this line that you see here is the intersection line between two planes. Yes? Is that understandable? Okay, now let me write the other one. The other one was what? 2x minus y plus z is equal to negative 5. Okay? Another one comes in. Let me change the color this one so that we can differentiate between them. So let me make it green. That's good. So now you see, this is complicated scenario, you know. I don't know if I can zoom out or zoom in. Yes. So this is, so far, we have the situation. If you want, I can get rid of this line. So this is the situation that I have in a space. Okay? Okay, I just want to see, if I give you this from the beginning, can you tell me how many solutions are there for my system as a whole with three equations? And how do you come to this idea? Yes, Tim? How do you understand that is one?
Because there's only one point on which all three planes intersect.
Exactly. There is only one single point lying on the same three planes simultaneously. Let us bring this back. Yes? So this line that you see so far is the intersection between the blue and the red one. And then you see the green plane intersect this line exactly at this point. Yes? So let me just do that. I go here, I click this one, and I want to find the intersection between this. I don't know if this is not possible, I think. No? How should I find? So I don't know. Is there any way to find the intersection using GeoGebra? So this one, let me see. Yes, that was the intersection. So you see this single point you see here is the intersection between this blue line and the third equation. So that point, you see, -6, -5, and 2. And that was exactly the numbers that we get when we solve the equation algebraically. Is that understandable? This is optional completely, but I want you to expand your perspective to see that it becomes really complicated from geometrical point of view. And immediately you understand that is the ultimate way. If I go with 4 equations and 4 unknowns, there is no way to think it geometrically in this way, because I need an extra axis and I don't have it. I can have at most 3 perpendicular axes in a space, in the universe that we are living. Yes? So it means that that would be more or less the ultimate way that we have to stop if I want to just work with geometrical point of view. So at least I hope that you understand what is going on. Yes, this is completely optional. I don't expect you to think about it if you don't like it, but it is really helpful to understand that there is a very nice interplay between geometry and algebra. And both of them are important to understand. Any questions here? Okay, let me just bring the axes back. So that was the situation. It was a little bit more complicated, and then I can also bring this point plane here. So this grids that you see is the ground level, and then if I move this a little bit, so you see that this is the situation that I have. And that single point that you see here, I can make it a little bit bigger probably. Here, make it bigger. So that point that you see there is the only point that lies simultaneously on these 3 planes. And the coordinates of that point are these numbers according to GeoGebra. And you see that these numbers, this is the x that I got in my algebraic solution, this is the y that I got, and this is the z that I got. Yes, that is the interpretation from algebraic point of view. Any questions? Okay, and of course I told you that that is also a good option. If you want to solve your system using GeoGebra. That is also one part of the book. Might be I will skip that one. We consider this as being this. You go to CAS view, and then what you have to write, you have to write solve. Let me just repeat that one. So you write solve, yes, and then you get a lot of options. This will be solve list of equations, list of variables. You choose. But in GeoGebra, you have to put curly brackets for the list, and then you type your equation. So it is x minus 2y minus 2z equals to 0, comma, and then you have x minus 3y minus 5z equals to minus 1, comma, and then you have 2x minus y plus z equals to minus 5. And then after that you go to the list of variables, and then you write the list of your variables. They are x, y, and z. And after that you just press enter, and then you get these numbers. So the solution to this system is x equals to minus 6, y equals to minus 5, and z equals to 2. So that is also good to know. Sometimes the problem is so complicated or boring, you want to use GeoGebra to solve it. This is the way that you have to do it. But remember, you have to switch to CAS view and then do the calculations there. Okay, so let me pause the record. Okay, so yeah, I don't want to continue. Of course, I don't consider this to be complete. Next session, I will solve a little bit more problems for you regarding this, okay? But more or less, I don't think you will face a big problem. So I will update the Google Classroom. If you are in case interested to continue yourself, you can continue on your own. Any questions? Okay, thank you.